Hi guys, so today we're going to work with complex numbers, which has a real and imaginary value. So notice it's asking for the conjugate of z. A conjugate is a real and imaginary number when you solve it. One has plus and the other has minus. And as you can see above, that comes from the quadratic formula. Remember, when we're solving, sometimes the square root will be an imaginary number and the result is one is plus and the other is minus. So keeping that in mind today, we're looking at the point given to us, which is z. So we don't actually have to know the exact value of z. We just know it's in the second quadrant. And in the second quadrant, we know that the x value or the real axis, would be negative, and the y value or the imaginary axis would be positive. So we can just make up a number to start off with as long as it has a negative real number and a positive imaginary number. So negative 2 plus 3i will do. We're going to write the conjugate of it. So remember, when one is plus, the other one is minus. Then 2 will stay negative though. So we're looking for a value that's negative in the real axis and negative in the imaginary axis, which would result in quadrant 3 or point R. So moving on from here, this time they're going to be a little more exact by giving us the two values for z sub 1 and z sub 2. So z sub 1, we'll start off always with the real number, which would be negative 6, and the imaginary number is also negative 6. So we'll write it as negative 6 minus 6i, I noting the imaginary. And for z sub 2, z sub 2 is actually on the real axis, the real number being negative 2, and we could write it as plus 0i because it's 0 on the imaginary axis, but we'll leave it as negative 2. So from here, we're going to multiply the two. Z sub 1 times z sub 2. I'm going to replace the z sub 1 with the value negative 6 minus 6i, z sub 2 would be 2. And because we're multiplying, I'm going to switch the order because 2 times 3, 3 times 2, it doesn't matter the order. When you multiply, it's the same. The reason I'm switching the order is because now I can distribute, giving me negative 12 minus 12i. So remember that I'm looking for the point that represents this answer. So the real axis should be at negative 12. The imaginary should also be at negative 12. And at that point, we have point S. All right, guys, I hope this helps.